Awesome. That way, there's a nice recording of this demonstration for you guys to refer back to later. Sounds great, Emma. Sounds like a plan. Cassandra, Kyra, awesome. Hello. Hope everybody's having a good Thursday so far. Usually my favorite day of the week. Okay. While we're waiting, anybody playing any good games right now? I just finished the new Halo remake from Halo Studios. That was kind of interesting. It was all right. It was fun.
I've been enjoying Pacific Drive.
Oh, that's a good game. That's fun.
Lots of car repair.
Cyberpunk, okay. Yeah. Yeah, I'd say I don't want to be too critical offhand, but I think so it's pretty. I'll say it's pretty. And I think the gameplay's okay. I think gameplay's good. It's just it's fairly unperformant. One thing that I noticed is that like I'll play it because bought it twice. I bought it for my PlayStation, and there are some sections where it's like 10 frames a second, where there's like a lot of enemies on screen. I was like, on a console, that's crazy. And my work machine that I've played it on, it has a 5080 in it, and it's still like it can't render. I'm playing on like a 1440p monitor. It can't render at like native resolution, and it has to use DLSS. So it's a little bit of yikes. I don't know if that's the fault of the tech artist. It's probably the fault of management and just not having the time to optimize things. But it's poorly optimized. I'm actually kind of curious about doing some render doc um, profiles of it, just to kind of tear apart and see see what all the problems are. Because I'm sure there's many. Okay, let's go ahead and get into it. All right, so I'll go ahead and share my screen. Okie dokie. Can everybody see my screen? You can give me some emotes. Give me those emotes in chat if you can see my screen. Let me be over here. Okay, cool. There's also like a react button that Zoom has. You guys can click that. Yeah. Awesome. Okay, so we're gonna kind of go over how to build like a basic little scene like this, which is kind of like that base layer of terrain before you might start adding your scattering assets and doing and your level designers and environment architects doing your set dressing. This is the type of thing that oftentimes is handled procedurally by procedural technical artist or procedural environment artist. And we're going to utilize, we're going to talk a little bit about materials today, and we're going to talk about um, Houdini. Okay, give me an emote if you guys have ever used a tool called Houdini before. Oh, a couple people. Okay, that's fun. So if you're big into Houdinis, this might be a little bit of a review for you guys, but for everyone else, this might be a little bit of an introduction. Um, so this is Houdini, and it's a fun little application. And what it is it's a procedural application. Okay, so instead of you make the chair, you can build procedures or build instructions to, generate a whole variety of chairs or different types of things. So if you've used something like Substance Designer, it's very similar to that, but 3D rather. And so you can definitely use this viewport. They have pie menus and all the things. It's actually quite art friendly these days. But really, we're going to want to build things for this demonstration that are quite procedural. So we're going to use a different desktop. I'm going to go ahead and switch to a custom desktop. You can, move these and you can edit things. You can uh, split, make new things and whatever. But I already have one kind of built up that I think's more optimized for this. So I'll switch to that. Really, I'm trying to maximize this network space. Okay. And right off the bat, Houdini has this concept of like domains or little spaces, okay? So up here, there's like these different little spaces where you can do image compositing, kind of like Substance Designer. You can do rendering, and some of these you can do USD layout. But the most of our work will usually happen in the object domain, which is kind of if you're used to like Blender or a tool like that that has like this edit mode, object mode. This is kind of like the object mode where you can set up little containers to put things in, as well as put out lights. But if we dive into any of these containers, let's say if I make a new one, I'll just turn that one off. This one, I'll just call open day demo. Okay. Now the word up here will change from before where it was objects. Now it says geometry. Okay. And this is where most of the work happens. This is where we're going to work with things called SOPs. Sometimes when you hear people talk about Houdini, they go SOPs, tops, or ops. They hit, it's all this, they're all talking about their ops, that they have a lot of enemies, but that's a little bit of Houdini speak. An op is short for an operator. It's a term we use for a node. And a surface operator is a term for like surface operators. Okay. So, SOPs. Tops are like task operators, rendering operators are called ROPs, compositing operators, COPs, so forth and so on. Okay, so there's all kinds of cool things that you can do here. And we're always really thinking about data here. So let's say if I were to drop down like a grid, just as a demonstration, there's a couple things you could do before you get into the terrains. All right, here's this little grid. I'm gonna make it smooth wireframe. Let me actually put a timer on because sometimes I ramble. So I want to make sure that we have time for questions at the end. Set a little timer. Okay, awesome. Awesome. Put that on the side. Okay, let's say that's that. Let's say we have some test geometry. I just drop down this little toy, cute little toy. Uh, Look at this guy. He's so cute. Actually, it's fun. At GDC, they're kind of giving he's getting blurred, these little squishy versions of him. There's also another one they were giving that was kind of fun. Everyone loves this one, which is the pig head, which seems kind of strange. It's like an old graphics reference model from like the 70s or 80s, like it was a photo scan of a pig head. It seems a little morbid, but you usually see people test with this one a lot. The main reason is like pigs have like very similar skin properties, anatomy properties to humans. So like subsurface scattering, a lot of those actually will be quite similar with the pig head. Or you can test that in that context. Anywho, we'll stick with our cute toy. Let's say I could drop down a scatter stop, and we're just gonna scatter some points. Okay, so we have this geometry I can kind of preview, and we have these points we've scattered, and I'm gonna put it down to say like 10, or maybe I can go a little bit more than that. I'm gonna do like a copy to points. Put my little toy over here. And right now we just scatter those little points, and that's one thing we can do. We can come back up here, we can change the amount, and we could start changing the attributes. So if I middle mouse click on this, we'll see these are points. They have just the position attribute. This has geometry, it's a polygon, has normals, and has all kinds of things. We could change something. Let's say just right away, I'll go ahead and get rid of the material on this guy. We don't need to see the wireframe. I'll go attribute randomize. Okay, and this is gonna add a random color. So now if I middle mouse click, we'll see CD, that's our color intrinsic. And we see these little color points, and I can actually visualize this a little bigger, hit D here. And you can make those point sizes, bigger. So you can just kind of visualize these new points. And now when we've copied that data will be kind of transferred to our little guys. And even let's say if I change the base geometry that we're scattering on, say sphere in this case, and let's say I make my sphere bigger, all right? But maybe I want something a little bit more unique. The sphere by default it's a polygon mesh, but it may not have any normals. So if I do a normal SOP on this guy, it will now have normals, and we can kind of see those normals. I'll do them as point normals. And Now all the points will have normals, and those can be useful to help orient our little dudes. And now our little dudes are oriented in some way. And kind of how it works, you can use an orient attribute as well, which is criterion, but if you just have a normal attribute with your vector 3, that's going to work as well. And how it kind of wants to work is like this. Normal is kind of when you copy something, that normal is transposes the forward vector. And the forward vector in our case is by default always going to be z forward. Okay, it's always going to be like, blue line z forward. So we just want these guys probably to show up like they are instead of intersecting with the sphere, like they're sitting on it. So for that, we can probably just rotate this little guy. Maybe we'll just rotate him like this, the other way. Okay, and now if I were to merge our sphere, they're all sitting on the planet. So cute. Okay. And this is like one way you can kind of work up and down in this graph working procedurally. Now, this guy didn't have a color, so it's doing that black thing. So we can just drop down a color, stop giving it that color attribute. And they're all kind of sitting on the planet. So cute. And that's just like one, example of really basic workflows you can do kind of procedurally. Okay. Now, as you get, more complicated, with especially with topology, with geometry, there's all kinds of complications that can come up with working with topology in the best pop ways procedurally. And uh, there's kind of this whole workflow that we want to get as much of the orientation of our data at like a low scale proxy and then build up from there. So we have one, in this case, an example of that is, we are putting and we're authoring all this data on points that then propagate to the instanced geometry instead of trying to write that data on the geometry itself. Do low scale, just in some proxy like this where it's easier to control. Luckily, for something like terrains, it's actually quite easier because in Houdini, there's a couple different ways of doing terrains, but what we're going to look at today are something called height fields, which is it's kind of like a volume. It's a two-dimensional volume, and we can treat it very similar to how we would just simply treat a two-dimensional compositing. So, the mixing of things, we don't really have to worry about geometry too much. We can just worry about uh, blending that gradient. So it's going to be quite easy. Let's go ahead and hop into that. We'll hop down a height filled up. And we'll just take a look at it. Okay. All right. So the grid, by the way, is just for visualizations. There's really is nothing here. It is with a mouse click. It will say it's a grid volume. And it will say it's a resolution right now of 500 by 500 by 1. Okay, and will tell me how many voxels it is. And you could set this to a particular amount, and really what you would set your size to is going to be really dependent upon what you're doing. And especially for Unreal, I would suggest, you reference uh uh Unreal Engine Houdini docs. They have some really great documentation uh on this type of thing, especially on landscape specifically, and what are going to be like the best outputs. I think under basics here, they kind of talk about the different sizes that you're probably going to want that where because it comes into Unreal as like a little height filled texture, so it's going to be like slightly off a power 2 because there's some padding. But for our demo today, we're just going to keep it with these default sizes, which is really close actually. 109 would just be what you just set it if you were going to bring in the engine, but it all depends on exactly what you're doing. I can drop this actually into the chat so you guys can add that to your personal wikis and notes. All right, anywho, so just like with anything else, let's say we make something cute, like a little mountain range or something like that. Um, when you're making something like terrain, or you're making something like a texture, procedural texture. We really want to think broad, similar to like when we're thinking of doing like a painting. So we're going to want to do those big macro shapes first, and then we're going to move into our medium kind of shapes or patterns, and then we can do some of those micro surface type of details. So what I like to do is just a couple different ways you can do this. They have a number of different patterns. Like they have this height field pattern. They also have a number of different noises. The height field noise. And really depending on what you're doing, some of these might work for you differently. I'm gonna go ahead and turn off my grid and turn off my wireframe because it's a little distracting. This one's kind of fun. They have a click here. They have and if you're following along and you don't know, hit P can kind of make this come on or off. They have these different patterns. I'm not quite sure if the star one's that useful, but there's all kinds of interesting things you can do where you can change that shape and maybe get use this as bunch them up and use it as a base for like a hill or something like that potentially you know. But really, these are decently okay because you can use the stripes or these ramps sometimes to create like patterns like for deserts, for desert patterns. I tend to use those decently. I think there's an example a little later we might take a look at for that, but for mountains, they're not nearly as useful. For noise, I think is a great way to start. So we'll start with that. Let's say we take a look at the noise here. So they have a number of different things, and what's really cool is in Houdini, a lot of the implementations are fairly universal. So you'll see like a menu once, and you'll see it kind of the same everywhere. So like this is, a bunch of different noise types, and then they have a fractal way of doing layers of noise. But if I were to go back to Geometry World, let's say we have this grid, and just like this was an attribute randomized, there's another kind of attribute noise node. Okay, let's say I give my grid. I'm just gonna make it bigger so it's I don't have to zoom in. Well, and I've also, increased its resolution, so now we're around 1 million or so polygons. And I'm going to right now we see this crazy, almost looks like white noise, but I can change this element size of this noise. Right now it's on the color attribute and kind of see, like a color output. And we could look at different types of things. It's almost like a whirly noise. Um, but you see like the noise type is relatively the same type of menu. And if I go to fractal type, we'll see it's a relatively kind of the same type of thing. Um, if I type in mountain, okay, what this is actually the same node as this. It just has some presets for position. So this is changing the position as an offset. And all right, so same kind of deal where it's just we'll probably want a much different. Let's see, what did I set this one to? 80 or so. So we'll want similar kind of deal, and I'll increase that amplitude and kind of see the similar type of noise that we had starting up over there. But this is with geometry, and usually you can do something like that, but you end up having to get something that looks decent or whatever to start with. You might have to use quite a bit of polygons, and it's better, to just start with to this type of things, and height fields will be faster. It'll be generated faster, but the menus are all kind of the same. So you can learn one context here and then carry that same stuff into other contexts like compositing and cops or with just geometry. Okay, so sparse convolution is pretty cool. I like to start with those big shapes with something of a cell noise, a Veroni noise, we might call that. So we'll go to Whirly, which is just a term for layered Veroni noise. And again, I'll turn my wire off. And okay, cool. I mean, kind of see this octave is kind of like how many layers of this that we have. And I'll just do maybe like 1 or 2 layers. Okay, and I'll turn this amplitude down just a little bit. And we can always come back and play with it. It's not instructive, it's procedural. And what I could do now is I could do another height field noise. Or what one thing I might do before that, I'll just drop down a couple nodes that we could play with. But right away, these lines are a little sharp and so on, and that might not be what I want to start with. That might be a little bit, Tron vibes. So I might just blur this first before we do another layer. So I can do an attribute, or actually rather a height fill blur. I could right there you can see it already softens down. I can control how much that kind of blur is. Okay, sorry, we're getting a little softened, starting to look a little bit closer to mountains. But I could do this. And already we have the base shape on top of this. In this case, we're using like that sparse convolution. I could turn that down, right? But notice that like the way it's adding it, it's kind of can really morph that shape quite a bit. And there's a couple different ways that we could do the combine method. We could try this blend, right? We could try an add, but it might be a little strong. So one thing I like oftentimes at this stage instead is using what this height fill distort. What it is, it's essentially you're using the domain of the height field, almost like the UVs, and there's a noise that's kind of doing like a UV distortion, a domain warping. So I can turn that on. It tends to work really well. So if I right now there's a curl noise, or it also uses a simplex noise for this, so it's very similar to what we were kind of using earlier. But you'll notice that the deformation is much more contained along the shapes that we already kind of have. And already we're starting to see our big base shape kind of come out. You can look at the simplex noise. And this is using an anti-aliasing noise essentially. I think the crow noise is better looking. We'll kind of reduce that down just a little bit. Okay, that might be interesting. And okay, that just might just work for our kind of base shape. And some other things that you could do is, there's a whole lot of ways that you can kind of control this you know, where you're putting features. You might notice that there are like a second little dot here, a second pin input, and that's a mask. So we can author little masks to determine something's going to happen in only one area. And we could just paint those. I could drop down a paint and hypo paint. Now, with painting, this is going to be a little bit more of a destructive workflow. So you usually would want to do this in a place after, downflow of your procedural work. So, things are a little bit more fixed. But, let's say I could bring my little paint guy and let's say I want just one area, let's say over here, it's going to be a cool base or something like that. And I want to have that be apply, let's say, one of these noise nodes. And now there is a mask here. It says mask, okay? And I can just apply this right here. And I'll go ahead and do a mask clear. That way it's easier to see kind of what's going on. And we'll see that as I play around with this, that is only really happening where we painted that, okay? But, there's also procedural ways of doing this type of thing. So if I could do mask by feature, height fill mask by feature. What it's going to do is kind of interesting is it has a bunch of different options here for creating masks well, by the features. So we can determine something by slope, and then we can determine like a slope angle. So that maybe there's a type of thing I only want to happen on certain cliff edges. I could also just use height, compute this range here, and maybe I want to have something that only happen on the valleys, or only happen, uh, and somewhere more shallow. Okay, maybe for example, I want to have, let's say, all these more shallow areas be flatter. Okay, so I'd want to invert this. Nice little mask invert, and then I could blur, or I could do a remap or a flatten. Let's say blur might just be good enough, and really blur that stuff to bits. And we could look at that clear, mask clear. Okay. And let's say we have, I think it's remap might be a way to do it. I put remap. So now that whole area has kind of been flattened out. It's almost like a little valley, which would be great to actually put gameplay assets or allow artistic painting and drive that some other way. But we could also just apply a small amount of noise there as well. Maybe we'll run this down just a little bit and play around with our element size. You just have you have a lot of control here as far as exactly how you may want to do that. We might even subtract that instead. That way, it's maybe pushing down in a kind of different way. Okay, and you could just kind of play with that as well. I could even do a high field distort on that. And it would be, and potentially it could be very similar. I think we just want to play around with the amplitude amount of this. I'll run this to simplex. You see how it's really is just a warping. It's kind of warping that space. So, with a very planar space, it can do some more interesting, odd things. But, with less octaves, we can just get a little bit of bending of that. In any case, a couple more of these feature masks that I'll tell you about that are kind of unique or interesting. Peaks and valleys is pretty cool. So, what this kind of does, really, there really is just peaks. And this example kind of tries to get you the curvature, essentially, along here with a more extreme kind of valleys and hills, especially if you have more ravines, you'll catch a lot of these. I think something like this might be useful to do after our erosion simulation stage. Additionally, you can do direction. This one's not as useful just because most of the time this doesn't really do something in the real world, but this is kind of like imagine there's a sun, it's like a shadow, right? So if we're lined up with that, so there could be an example or a use case where you actually do want to mask out some sections. Say, usually the sun comes up in the east and sets in the west, and there'll be a little bit of a procession over the season. So you would expect maybe um, certain types of patterns and erosions based upon that procession, but not particularly extreme, just because the only thing that would be different would be having that light angle that's orthogonal to it. Because obviously, if you have humidity and the sun's coming up in the morning, you're going to have that same thing at dusk, right? But the orthogonal axis, like a perpendicular to the sun's, zenith axis of orientation, you wouldn't. So, um, there you go. Now, so with smelting snow, um, probably you maybe wouldn't want to do that unless you were gonna have a game that 100% was not like dynamic. It wasn't like a day-night cycle, Cassandra. Like it was, this was like a fixed level, and you knew like this is actually a really good example. Let's say you have a landscape or whatever, but the level happens at a particular time. That's when it's a single player type of game or whatever. Then yeah, actually you could take some of these masks to drive that type of interaction with this type of direction. That's a good example. Inclusion is a kind of a decent one. It's kind of like an AO pass, essentially. And you can use this to get some interesting features, you know. Um, this one could even be a fun one um, to do right here. Let's say do this before we do all this stuff right here. Say right here. Um, and what I might do is I might just do a sharpen. So, just to help these edges feel a little sharper. And you can always toggle things on and off just to see. Okay, it feels like this is getting very subtle. So let's say we can do other things here, like expand, I think is a useful one. You can kind of push out, and you can also kind of do the opposite where you kind of push, you can shrink, and it kind of pushes in. So sometimes what I'll do is, especially with something like where I have a lot of veins down, I might kind of push that down a little bit to emphasize those cuts. Let's say I will just, in this case, expand. That might be fine or interesting. And we'll kind of keep going. Okay, it's a good enough on all these different masks. Let's talk about a couple other pattern time methods, and then we'll go to the simulation stage. The last one I kind of want to show you guys is something called terracing. This is a fun one. So I don't know if it'll work for this kind of setup we have right here, but this is just something that you can do that's cool. So this allows you to kind of create these type of artificial terraces. So this can be useful in two contexts. Like there are certain types of geology around the world that has like these little plateaus, like think of the Grand Canyon or Arizona and so on. Another context is say the mountains in China where people have created all these kind of, or Peru, Inca where empire where people have created all these kind of artificial terracing for agriculture. This is a cool kind of method to do that, and we kind of have the ability here to control when that might start, where that might, the range at which that might end, and then how many of those steps we might have. Let's see. Right. And also, we can offset through this pattern. And we can also kind of control how smooth that set is. And I can maybe even use a distort here to use this mask again. And say I'll bring the Alt click to duplicate a node. That was an invert. I meant to grab the clear. Say what I'm noticing a little bit, I think, is the distort is so strong. It's kind of pushing one section down a little bit, so it's looking kind of silly. Yeah, there we go. It's a little better. I can play around with this amplitude. Ooh, a lot of it's the size of this texture. Let's say we bring this back a little bit. And let's say also I put the mask back on here. And I kind of reduce the how much. So that can kind of make this from, zero where, they have this, they're smoothed in, but, with this kind of distortion, it kind of makes it look a little bit more organic. And that could be something interesting. And maybe that's worthwhile, it can be useful for like, oh, it's like a quarry side or whatever, right? In any case, this would be kind of a medium type of shape or so on. And kind of in the course of building these, a lot of times the macro surface detail, we can kind of do that, or kind of this medium level detail we do with each pass. But a lot of that also we might apply at the end. Now, up to this stage, you might be looking kind of okay, but it's not exactly where we need it. It's a little bit 2003, So where we can really go from here is with our simulations. And I'm going to type in erosion, high-field erosion. This is really great. This is a solver. It's kind of a built-in solver. It has a little lock. All these, by the way, fun little fact, all these little nodes are digital assets, Houdini digital assets, a type of asset. So you can build any section of things, right? And I could go Shift C, and what makes them into a little collapsed node. And I could right click, I can make those into a little tool, a little asset. I could even bring that into a different tool like Unreal using Houdini Engine. And this is the same way. This is a big preset of a number of different simulations that have been kind of pre-done for us. A lot of this is in a COPS context. This is done in this kind of imaging context in shaders. But really what it's going to do is it's going to simulate kind of this erosion. And what I like to do is just a fun way of doing this. I'll turn this back to 1, and I'll set this to height field visualize. And it's kind of can just put a little color on our dude. Okay, very nice. I'll get rid of this snow because I'm not feeling it. And we'll make this green, these greens a little bit more fun. Let's say, uh, okay, I don't need the sliders. Just give me the wheel. Okay, that's great. All right, cool. That's good enough. And let me just go ahead and reset this viewport real second. Okay, cool. And even I can push this down just a little bit. Yeah, I don't know. For some reason, in this latest version of Houdini, the viewport's being a little silly, where especially with these material shaders, it wants to continually not update. Okay, and that's good enough. Anywho, one thing that's fun is I can open up the timeline here and we can kind of watch some of this erosion happen over time. And that can be kind of a fun thing to do. So I can hit play, kind of can see that happen. And what's interesting is that if I middle mouse click here, we had a little bit of data, let's say up here, we have a little bit of data. Okay, there's some new stuff here called Mesa and Cliffs, and that actually comes from our terrace. So there's other data, almost like other masks that are useful to us, but we get a bunch of them from the erosion. The erosion gives us like debris, settlement, um, flow, so on. And there's different ways to kind of visualize. They have this kind of material kind of visualize thing right here. I guess let's say we look at our sediment. Okay, or let's say we look at our debris, or let's say we look at our flows. And these might be fun or interesting ways to kind of see that build up, right? So let's say we just do like a couple, let's say 4 or 5 frames might be good enough. Let's say we go back just a little bit. And I can use these guys. Right, it's already kind of cool looking, but I can also use that data that we have from those masks to do other operations. I could do, say, like a blur operation. And instead of blur, I might instead use that shrink operation. Instead of having it work on the mask, I'll have it use that flow. And let's say as I click on that, right, we can push that down or do different operations. Say even like blur on this. That's kind of funny. But you have kind of some openness to what you might want to do. Now, just like in a cooking show, I have a couple pre-made recipes to kind of walk you guys through, and then we'll kind of look at the example that we brought into Engine. So let's just walk through some of these different nodes. Okay. This one's kind of fun, and I think we have two little setups here. Take a look at this first one. You can just go all the way to the end here. This may have been actually from a previous demo. Let's look at these two rather. This one right here is kind of a fun little desert example. Okay. And so I use this pattern and we use these kind of stripes and to get kind of these little big wiggles. And a lot of that comes down to this is the base pattern. I just got from the rotating a little bit and getting the widths quite right. Okay. And then we were able to distort that with this kind of distortion using some noise to kind of distort that pattern. So it looks like our sand dunes that we're interested in. And I also have another pattern that's very similar that I built using kind of a ramp, just making a profile and kind of repeating that around. Then using a volume mix to kind of blend them together, and then doing a distortion with some curl noise to kind of get a little bit of that cutting in effect. And then I use this kind of flow fields, which is not a simulation, but it's actually calculating the derivative along the surface, what in math you might call the gradient, the 3D derivative. And it's using that to create a mask, a linear mask here that we can use to do operations. For example, like doing a shrink operation and then blur, and we can kind of clear that. We can kind of see that, we had to visualize, so we put a little bit of brown where that mask was. And that kind of works for really basic desert pattern, maybe even a really basic low resolution color mask that you blend with your tiling textures. For something else, this is very similar to what we kind of already had, but anything can kind of be brought over here pretty easily. So this is a template object. It's like a little head. Sometimes in fantasy games, you might have like something kind of crazy, like a giant that's died and he's a part of the landscape, or like the big snake in God of War or something. This might be an example of something like kind of like that. So in this case, we're height fill. We're going to just project that. And that geometry can just be projected into our geometry. And we can even use a project that mask using the same object, and we can use that to kind of blur this in, as well as do our flip that around and use that mask to do that blur on our edges, kind of like we had before, and do some of the things that we saw before a little bit. Okay, and then we can do a simulation on that and get something kind of looks like that. Okay, and we can use this little SOP here to export some layers. Let's look at the one that we actually have exported out in for Unreal. So there's a lot of things going on here, but we'll kind of skim through and some of the setups here and just show what we're kind of baking out for textures, and then how we're going to approach some of the geometry that we're going to generate. So kind of some basic things. This one is a little interesting. This is just, there's no right and wrong way to do things. It's just me playing around. So I use this bounds node. This actually create a geometry, a box. It's a very thin box right here. And the purpose of creating this box was just to something to easily move around like this. And then I project that, right? And I can control how far that projection goes, right? And I can play with this transform to control exactly how much of that we kind of get flattened. So I just wanted a slight off angle because really I'm just trying to get some kind of a cliff action going on here. And this is a cool one. This is a another type of cellular noise. So Worley cellular, cell noise, running noise comes in a couple of different flavors. We might have seen like the normal, what we will call cell or Worley, but depending on the metric, right, the way you're calculating your triangles, if you're doing like a normal Pythagoras theorem type of thing, like for your distance metrics, what we call Euclidean distance, that's a normal cell shading, but sorry, that's a normal cell noise. But they have a couple other ones like Manhattan or Cheshire or Alligator and so on. And these just do the math slightly differently and can give you different cool shapes. Uh, so Manhattan's a fun one as well. Like they have different use cases. I kind of like this sometimes for big patches as a first layer, especially I do some blur and that can kind of be interesting looking. And then I do a heavy distortion pass on that, and it kind of fills in that space and works decently well. And I'm going to do the use of flow fields again on that and kind of shrink down. That's kind of interesting. And really all this is, there's no shape or form to this. A lot of just playing around and getting something that feels like a good vibe. And we get kind of down to here. I'm going to clear this. And right now, this was kind of interesting. And even, let's say if that, I needed this style of cliff for the shot or for the game, that would be good. But I figured, let's try a canyon. So I just used the remap. And what's fun is because this is like a ramp, it's almost the same as being a linear gradient. So the same as being like a line that kind of goes up, which means that if you pass it into so a remap function, then it's the type of thing that like whatever profile you put into that remap function, it's going to perfectly align because it's just taking some linear thing that goes up, and that's what remapping does. So funnily enough, just by creating that curve like this with the remap function, it would take that ramp, and I think I changed some of the height on this just a little bit, so we're getting some weird artifacts probably from when I did this projection. Change this value right here. Um, there we go. Quit being yourself. Uh, so we actually got this little cliff shape right away that kind of works. And I could do this mask by features, just getting the slopes. I can do a little bit of blur on those guys. And I'll do a little bit of cutting away and run a simulation on that. A quick little sim to kind of cut down those shapes a little bit. And that's the basic shape. Um, as far as textures, I have a couple different approaches here to do the textures. We go all the way down here, but most of this is pretty straightforward. 90% of this is just going to be me doing different height filled passes, height filled mask by feature passes, and copying those to a layer and naming them. And it's going to be each one of these ones I'm just going to save to a packed texture. Uh, Essentially, I just want this inclusion, some of that curvature, some of those different features, and I want like a mask for the bottom, for like really close to like where this ri dried out river may be, and where kind of the top of things are. And I'll set these up to export out, where I'll map each one of these named things into the channel of a texture and export with these little height filled output nodes. Okay. I wanted something else. I wanted this vibe, this energy, this striations, these like kind of mountain striations. And to do that, I figured the best way to do it would actually have put that on geometry, use some geometry. So I kind of use a mask by features, and I kind of get close in the shape here to get something, these little silhouettes, because what I want to do is cut this out to be something to just slap on top of my mountain. And I use this visualize, and the purpose of this is just that it's gonna the mask here I've set to white. So when we convert this into geometry with the height fill convert, so right now we're in voxels, it says voxels down here. And now we're in polygons. So polygons versus, voxels. Well, that's going to be a color, and that makes it real easy. Don't worry too much about this. This is just to make sure things align on the grid properly so that when I export um, landscape components in Unreal, the pivots are on the corner of the landscape. This just ensures that when I output all this geometry, they're going to be in the same world space in situ. So they'll just all align. In any case, um, whole purpose of this color is I'm going to use this delete node. I'm going to delete by a little expression. Okay. I'm going to use this attribute at color. If it's less than 0.1, really just less than 0, it's going to cut those out. Wow. I have these little guys now. Okay. Now I need to make my little patterns. Okay. And what I'm going to do, one thing that's cool here, so you can link everything to everything in Houdini. It's very powerful in the sense of working with data expressions. So this is just a line, and this is just like this little curves, I could just build these out here and turn on the point visualizer. I can just add points to this or whatever. All right. But instead of kind of doing this by hand, I might go back and I might change things. So what I have done here is I've referenced by name this node, this little named node I named called reference. And I've gotten the bounding box, BB box, and I've gotten the minimum and its maximum. So like its origin is going to start wherever the minimum of uh this guy is, and the maximum is going to be the length. So this line will just always be, this curve will just always be the size, right? And what I'm going to do now is I'm just going to resample and just add a bunch of random points. This point gener node, I've kind of set this to be 0 on every axis except for the up axis. And that's just going to, kind of do a random assortment of the points that we resampled. Okay. I'm just also going to randomly sort their order as well, so they're not in some way. And I'm going to save that number. So the numbers you see, this is an intrinsic attribute called PT num. Okay. And funny enough, down here they have like a little thing called the geometry spreadsheet, and where you can actually take a look at all the data that might be on any given thing. In this case, we have a class attribute over here. This is turn those numbers off. There's all kinds of different attributes like color and masks and so on. You can kind of look at for every single point number, they correspond to the values here. So you're gonna be very refined. And it's one of the reasons why we want to kind of work with something that's a lower like complexity data, because obviously, there's a lot of geometry here, it's like 200K geometry, and going through, all the points, explicitly, can be like a little bit of effort. So working at a space right here where there's only a handful of points and we can kind of understand exactly what's going on and then propagate that data is how we want to work. Okay. Let's talk about the data we're actually going to create here. In this case, I just want to use the color stop, and they have like a setting here, ramp from attribute, and I just set the range here to be um my minimum and my maximum, and I kind of divide by two, so I'm just kind of play with that maximum a little bit, so I can get repetitions of that range. I just for the actual colors, I just kind of used my color picker. I went to my reference images that I brought in. These can be kind of whatever. I don't want that one. Uh, and you can bring in background images with this up here. You can kind of opens up your, can have any background image in your UI here. Uh, cool. Now, what I want to do is I'm just going to redo the UV. I'm just going to do an automatic UV on all this geometry. And for the way we're kind of in other applications, oftentimes automatic UVs are pretty bad. But in Houdini, you have a lot of ways of controlling the data in such a way that usually procedural UVs will be more than sufficient, especially with the way we might texture things. Now, right off the bat, we might notice if I turn this wireframe on that our topology is pretty trash. Um, right off the bat with how this converts. So we might want a little bit better topology. And I'll just use the fast remesh node to really what we care about. Typically, when you're modeling and so on, you care about quad topology, but quad topology isn't actually important. Quad topology matters as far as an attribute that has to be interpolated. And because in other applications like Maya or Blender or so on, you are really restricted as an artist about what you can do as far as the information and data. So if you want to control how something like a normal interpolates across a surface, really the only thing you have control of is the topology of the model. If you want to interpolate how the skinning and deformation of a model will happen, really the only thing you have control over is topology. So we'll work with the tools, and we will the best kind of tools we have are working with edge loops and so on. So we'll make a really good type of quad topology. But in the context of procedural approaches, we don't really care about the topology. Topology is just one step to get the actual attribute, and we can just write those attributes independently, and we can run those attributes regardless of how the topology is. So we can do work in tries, and that's fine. In this case, I just want equilateral tries because it's going to be, the most even uniform distribution of an attribute. In this case, I'm going to transfer the color. So we have this kind of color that we have, and it's kind of, you can kind of see it's on this grid here. I'm going to sweep that just so you get an idea of the different color, and I'm going to transfer that. So kind of those colors are in this transfer to this geometry. Okay. And that just works, right? And it's simple, right? So we didn't have to think about authoring and interpolations across all these different triangles and processing all that data across every part of our step here as we're making decisions on, 100K or 200K of triangles, instead just on a simple line, and we can make decisions and change things there where it's fast and cheap, and then we process that onto our other geometry. And I could do some other operations to kind of blur and make this a little nicer. I have something right here where I'm just going to create a small little group of the outside points, and we're going to use that to create a small mask that's going to be useful later for blending things into the landscape. Okay. All right, so I'm going to hop in here. And right here, we just do a little bit of extra stuff. You might notice now that the pattern's a little different. I'll turn this guy to smooth, and I'll just put his, right here, so we have a little extra. And what this is I've just created a couple other patterns. In this case, it was with noise, right? And in this case, we just used an alligator noise, and we just set the size, the frequency size, if I were to copy this guy to everything. All right, so this is kind of like the base pattern, and we just set it to 0, so it's kind of infinitely stretching that super tiny in those directions, which makes them kind of like lines, right? And that kind of is interesting. And I use this ramp right? And it's going to propagate that to an attribute out here. I did the same kind of thing with this ramp and picked fun little colors that were interesting, and we could look at that on the color. And then I have another I have a mask here from that came from the solver, which is just these debris lines from the sim, as well as just another uh little noise with a little basic purling noise to give this no this mask. Okay. And I just kind of played around with different numbers until I got something fun. And then I also kind of added these together, did a couple of things, just kind of playing around to get a good looking mask. And let's say this is the output of that mask. Okay. With both of those mixed together. And I'm going to use that to lerp. I'm going to use that to blend between our existing stuff that's coming from our line technique and then what we're getting from our noise. So just a couple of different things. These are our two inputs into our blend, and this is the output. Okay. So what I'm going for here is sometimes you'll see uh, the beautiful um, result of thousands of years of violent tectonic action, where two tectonic plates, something along a fault line. You'll see this in the mountain ranges around El Capitan and other places around the San Andreas fault line and other fault lines where two mountain ranges have kind of ridged against each other, and you'll see separate striation patterns. And a striation pattern really is just different layers of different styles and rocks that have compressed over millions of years, and then they moved and they hit each other. So you have this mountain range where you have two patterns that are going kind of opposite kind of directions. And that's because the striations were built before those two mountains moved into each other. And that's kind of the type of thing we're kind of trying to represent with this type of mask here. And I think it's worked decently well enough. And the last thing is just I also want to use this pattern. I kind of turn it into a grayscale. And I'm going to use this also as a displacement amount. So I'm going to use this grayscale to displace because I want to displace this geometry a little bit. And then we're going to output it for as nanite meshes. I'll put that in as a displacement scale. Additionally, is for output, I won't actually hook this up just because I want to be able to see everything. But we have a mask here called edge, and that comes from that group that we created. And I'm going to put that on the alpha just because we're going to output the color, and we're going to output this alpha on the vertex color so that I can sample these. And most of the texturing for this is going to be done with tileable textures and the vertex color. But just so that in the viewport, the alpha is obviously going to make everything invisible. So set just to one so we can kind of see what's going on. Okay, let's put our color back in here. Boop. Okay. And I can kind of blur these attributes a little bit. And we're just going to get to this point. I'm going to do a smooth operation. And then I'm going to do a little subdivision. And now we're, kind of around 4 million, 3.5 or so million tries. This is going to be this could be their setup for high poly pieces that you're going to bake to low poly. Or in my case, I'm going to use this for a nanite mesh. So I'm going to use this node here called triplanar displace. Let me turn the lighting on. And you can kind of see that we get some decent looking topology. And really, it's just in this case, I'm giving it a height filled texture. And I guess I could maybe go find where that one is just so you guys get an idea of what's going. It's just a mega scans type of texture. Something kind of like this to kind of displace this geometry. And it's just doing that with a little bit of noise distortion and triplanar mapping. So it kind of really just works out of the box. But importantly, I'm using the displacement scale attribute that I created, and that's causing this to displace kind of unevenly, where some of these are getting displaced more than others. And that's going to help sell the realism of the striation patterns, because you'll notice that the patterns are going to be kind of different. I'm going to soften these guys. I'm going to just get ready for export. Okay, and this is a ROP, and this is kind of how we export an FBX. And this is all kind of procedural. So the way I've set this up is it's going to delete by just and show each one. And what's cool about the setup here is that this is a batch operation. So if how this kind of created things or create the different pieces is how if they're connected or not. Okay. And that connectivity happens by this just by the original mask. Okay. So if I go upstream and change things, I might not get, I could go and individually cut each one out, but if I go up and change things, this isn't going to work anymore. So this is a little bit of a batch operation in the way that I have a little tool here that will create attributes for me. And then we'll go through a process. If I right click and generate this node, it'll kind of create a bunch of attributes across every single line to actually pass back. And for purposes of time, because I have to rebatch that, all these different nodes have a reference to that type that P, which stands for uh, P PDG, procedural dependency graph. We'll get that attribute. So this is the one way in Houdini that we can do a lot of batch operations. This actually is a whole nother context called tops, and you can do wild stuff in here. Really at kind of crazy stuff in here. Really, at its core, it's kind of like a way of doing command line batch operations with nodes, and there's all kinds of crazy things. So you can make huge automated pipelines. You can even do like machine learning stuff, synthetic data in here. It really gets outside the scope of this tutorial. In any case, at the end of this, we get an export of a number of FBXs, and we also get an export of a number of height field textures. Going into a rail, using the landscape mode, right? And let's say if I go to manage and new, you could import a new one, and they allow you to import these based upon import from file. Oops. And you can just use that height filled texture, right, that we exported out. And I've already kind of done that in this case. And I've already exported out a number of these terrain pieces. Okay. And the way you would cut these up, you might also have some procedural approach to cut and splice them if your world is divided into like world partition chunks. There's other approaches that you might do for this, but this is a bit more of a simple kind of setup. Let me kind of show you guys. Let's just look at the base color, look at unlit, kind of the different texturing passes, and we'll look at the landscape first, and we'll kind of look at some of these guys. I'll go ahead and toggle them off. Landscape's pretty simple. It's pretty simple for a landscape material because we're not really doing too much complicated complications when it comes to layers, but we'll take a look nonetheless at our landscape material. In this context, a lot of these materials are materials that we kind of show you how you could make some of these textures. And I think some of them are I think two or three of them might be Megascans kind of things, and other ones are ones that we kind of build during the class. And we have a material function here that kind of does the basics of, in this example, it's kind of simple triplanar mapping. And we have a base color, a packed texture of AO, roughness, and height, and a normal. And we kind of are passing those out. And we have some nodes to kind of help our displacement and also do control our normal amount. And we just have these different material passes for different cliffs, a sand layer, and kind of a mud cracks looks really nice, and that's gonna be useful for our riverbed. Okay, and the rest of this is those masks. So these are those masks that we kind of output from our terrain. All right, so this is like this is our AO, and it's our curvature, and this is kind of another curvature pass that we're going to use. Additionally, we kind of have these are those different features. This is kind of the sides, kind of the more close to the bottom, and kind of the veins. I think this, yeah, this is I think the one we kind of get from the simulated data. I think mostly. And what we have here, this is our gradients. These are those more broad masks, kind of gotten from our height, and we can use these. So, essentially, I'm using these guys to blend. So I can use these blend material attributes. All these guys, basically, in Unreal, we have kind of this Uber shader kind of concept with default materials. So if I turn this off, we'll see there's this big stack here. You can just collapse all these down to a big pin called using the material attributes. And the same thing as a lerp or a blend, you can blend that whole stack using these blend material attributes. I'm just using these different, um, I can just start previewing this node, for example, and we could see that. I'd say we may not be able to super see it because right now we're seeing on landscape coordinates. So it's going to take in the coordinates of a landscape. Obviously, it's not a landscape in here, but we just put it in texture coordinates. This is kind of the texture that we're kind of looking at. Uh, and each one of these sections are kind of blending these different materials onto each other. And at the end here, we're just bringing in those different details and like that curvature to just affect how the color is just a little bit. We're getting our color with the get material attribute, and we're kind of just multiplying it by that patch. Just a very simple way of affecting the color. We're just making all those as little attributes. And then we're also outputting this to virtual texture, which we can sample for blending. All right, and now in the material instance, we can kind of look at those different things and kind of play and see exactly what's going on here. So we have, oops, I meant to do this. We have those different kind of blends here. As I kind of, let's say, use the flow one, we can kind of see where those lines are getting stronger or weaker from that mask. As well, we have our different passes, and we can change like a normal and also like the uh the size of this and the tint. So let's say if I come down, put this in color mode, I fly my camera back down, we have this nice like pattern right here. I can kind of play around with that sand. It was far one. I can kind of play around with the size of this pattern, right? And I also have an alpha offset on this, so I kind of maybe expand how far this kind of goes. So now that's kind of shrinking it, right? And we're seeing more of our sand kind of pattern versus making that dried out riverbed, more than what it was before. And that's just allowing you to get a little bit more procedural reuse of the texture outputs. In the sand, if I tile that up or down, we're seeing more of that kind of those bending kind of shapes. It's kind of fun. And these all have like little color tints to them, so I could make this, some fun thing, kind of match a tint there. But this is the type of controls that you want to give to an artist so they can have a little bit of freedom of things as they go along. And that's kind of the basics of the landscapes. And you'll see a very similar kind of approach with the kind of a similar approach with the terrain, with the canyon cliffs. So let's say if I click on one of these guys. And what's important is that when you're making things in 3D, you want to be building master materials, okay? Which is a material that can be used in a bunch of different contexts. You don't want to have a bespoke kind of shader material for every single thing because that's going to increase your the performance of the game. It's going to have a lot more draw calls. So here we have kind of a master material for the cliffs. And if we go into that master material, this is the instance. And we go open that guy up. It's down here. See, what do we have? Well, I'm reusing that same function from earlier, and we have kind of a tiling texture. Actually, the same cliff one we're using in our landscape material. And I am passing all these things in here. And I'm also multiplying the output, that base color, by our vertex color. And then the two other things I'm doing is I'm using the color of the runtime virtual texture. And a runtime virtual texture is quite interesting. So a render target is this kind of cool feature in the graphics API that allows us to write or draw to a texture at runtime every frame. And that's done on the GPU, so it's relatively fast. But it still is something that's happening every frame, so it's the type of thing that you want to be a little bit concerned with. But one value to it is, this, I have a setting here called RVT blend. This allows us to help blend this with the terrain more. So it's really the RVT, the runtime virtual texture, is essentially a really fancy version of that that can is storing like a whole material, right? So in this case, we're all the material attributes that we've kind of have here from our tiling textures of our landscape, our normal, our roughness, specular, all that stuff is being passed into a big RVT. And that RVT is RVT is kind of this guy right here. Okay. And you can kind of set up exactly what you need in this case for storing base color, normal, roughness, and specular. So in the instance, I can actually kind of right here, I can kind of play around with that, and you can kind of see, let's say even set this to unlit, and you kind of see, let's say I set this to 0, and it's quite different. It's coming straight from the tiling textures, where if I set this to 1, it's almost exactly the same. But what you notice is a little bit of a weird stretchy stretch. And that's because this is a planar kind of blend. From above, it looks ex almost like nothing's there, right? Like you can kind of toggle these guys on or off. All right. And it's really a projection. It's a planar projection of that texture. So, doing a little bit of both, I think you get something interesting. You can even, the way a linear interpolation's done, is if you actually go outside the 0 to 1 of your alpha, it can actually have a like a multiplying effect. So if you go a little bit into the negative, a little bit into the positive, you can have some other blends, but it can become a little extreme. So it's almost like we're doing an inverse multiply. I multiply then complement by 1 minus x. And same thing, if you go over 1, it can do like a multiply effect, but it can be a little strong. So I would say only go outside the 0 to 1 very subtly, uh, and then saturate after the fact, so you're not out, you know, breaking your maths. Okay, but that oops, that's just one thing that you can kind of do or play around as you're looking at what might be the best way to kind of blend these guys and get the best look. Right, that's kind of interesting, but it might be a little bit too deadpan. Something like that might be good. So we get a little bit subtle color variation, but it also looks like it's of the same tonal qualities as the rest of the landscape component. Right. I might even go a little less than that. Okay. Um, yeah. So we have a lot of the other cool stuff, and we can also offset our mask a little bit. You can kind of see that blend right here. And another really cool thing is, let's say this is another method that's really, really cool. That's kind of an old school method for blending is, sometimes I think someone mentioned in the chat, like something called mesh blend. Got to get mesh blend is mesh blend is, I'm not a fan of that particular plugin just because that workflow is a little um, technically dependent. Really, it's, uh, it's an external plugin and it's built upon having a certain number of uh data channels to do blending. So there's a little bit of limitations with it. And also it's performance wise, not that the performance bad, but you can get the same effect with much less performance. It's well, I will say it is cheaper than RVTs, but doing a dither with pixel depth offset is cheaper anyway. And also with the new stuff in 5.8 for mesh terrains, it seems to be entirely pointless because you could just use mesh terrains to do the same effect and it would be better performance, or it's already built into the engine. Also, that's a insanely overpriced plugin, so I don't even mess with it. Yeah, but it's what I'd say about it, Michael, is it's easy. Well, I will say from an artist perspective, it is way easier than setting up your own shader. Uh, it is overpriced, but when you look at the demos, I'd say maybe look at some of the tutorial videos on setting them up, and you'll see that it's a little bit more technical to actually set those up. Once you to set up exactly how it works, because you have to set up these particular material indices on meshes, and you get like they're doing custom primitive data. Really, is how they're doing that, and they're sampling custom primitive data to do like they're a custom buffer in and in a global shader in their code plugin. Um, So now, um, I would say there's really great Unreal, like Emerald Dev Days talk on mesh shading, sorry, mesh trains, which this is not, this is a talk more on like the traditional landscape tools, but this new tool they've come out with very recently called mesh trains actually can do all that stuff and more. And it's a little bit even easier to work with even. It's like you don't have to get into any kind of technical stuff as far as the shaders, and it's easier actually. So that's already built by the engine for you. I would say I would suggest just to play with that first. If you can't get that and you think you need something like mesh trains and you can't get something from like these approaches, I'd say I'm confused about what you're doing. But and two, maybe you could try that type of plugin. This technique I'm doing here is kind of neat though. So we had that mask for the edges, right? And what I want to do with that mask is I want to blend in. And I'm going to turn this guy to 0. Okay. And we'll see we get these little harsh lines, and that's not fun. Okay. So what we want to do is I want to use my talk about my surrealist painter friends. And they had this little concept, this technique called pointillism. It'll take the little paintbrush, you can point, dot, 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 a bunch of little dots, and you stand back. So, oh, it's a thing, and that's an illusion. Okay, and we can use that same principle to fake translucency. Translucency can be a little expensive, so instead, this cliff material is a masked material, or you can do this with masked materials, but even better, you can do the same thing with a masked material and the same technique I'm going to show you, but you can also do it with the pixel depth offset. Essentially, we're going to take that mask, and I have the ability here to kind of blend it, and I'm going to use a dither pattern. So this is a node that's built into the engine here called dither temporal AA. If I open here, there's just really a really fine grained, small resolution texture. And that's just going to give the impression of like a bunch of tiny little black and white dots. And that's going to be our mask, okay? And if this was into our opacity mask, this would give the effect that some little dots and pixels are white, some pixels are black, and it will give this little dotted pattern. And we can use that to fake translucency or fake a blend, especially if you have like some AA or some other blending method that can blur on top of that. It can work. But for our context, this is being sampled in screen space, so it's going to work for us decently well. What we're going to do is pass it into the pixel depth offset. And the idea with this is in our shader, we're doing something called deferred rendering. Okay, that's like how this most engines work these days. There's this concept called deferred rendering. So you have all these inputs in here, and they go right? They go to this big stack for base color, metallic, roughness, normals, and so on. And this is data, this is your output from something like Substance Painter. But ultimately, that is used behind the scenes in the engine to calculate lighting, calculate what they call a BSDF, a bidirectional scattering distribution function, which is a fancy way of saying it's going to be used to calculate where our highlights, our microsurface detail, our uh, microsurface facets, the fancy way of saying highlights in a physically based model. And it's also going to be used to do our diffusion, take our base color and do a diffuse pass. Most of that really just has to do with taking a dot product between some lighting vector and a normal vector. That's why we need the normals. The normal is just a unit vector on an orthogonal to the surface of our geometry. It's just some pointy arrow that tells us that's coming out of our surface and tells us where lighting is going to behave, right? If we think about a ball and you bounce it, or you're playing, I thought bear pong about is say you're playing ping pong and you are bouncing a ball on a table. That direction of the table is going to determine the incident angle coming out. So the angle coming in will get reflected if it's perfectly level. If it's to an angle, obviously it's going to affect how it's going to bounce back. And that's really what the normal um is telling the shader. And mathematically we do that with a dot product, obviously, because the dot product, if you have two vectors, it'll kind of tell how similar if they're aligned. And another way of saying that is it's going to take it's going to be a projection. It's going to take the magnitude of those two vectors and multiply them by the cosine of the theta against them, meaning that it's just going to tell you how it's going to come out the other way. Okay. Now, essentially for lighting, they just do two of those. One of them's going to be for like your form shadow, your basic form shadow, and the other one's going to be for like your highlights. Okay, that's really what this does. But what they want to do, all that ramble is expensive. All that I just talked about, that BSDF, and that PBR shader is expensive. So instead of doing that for every single little object, okay, how you would do is something called forward shading. Instead, we send all these different passes, metallic, base color, normal, to a buffer, and we store them in a buffer for every single object. Okay. And then we pass those to do all the maths. Okay. And it's kind of done in a particular operation. So things get deferred. An object that might be in front of the camera, we calculate all these things into these inputs, and then we defer that. That's what the deferred part means. The pixel depth offset allows us to push the pixels of one object, so like because there's an object order here, right? There's an inclusion order of, this cliff piece is in front of that terrain. This allows us to push these pixels past things that are behind it. And if we use that dither mask, right, where a mask it means that the parts that are white are doing the thing and parts that are black are not doing the thing. It means that that mask, that dither mask, which we're then multiplying by that edge mask, so it's only going to happen on the edges of our geometry. Okay. Well, we're going to be pushing some of those pixels past the terrain. And it's going to give us almost like a translucent like effect. It's going to give us a dithering kind of blend here. So as we had the thing earlier where we looked at this and we had this situation right here. So as I turn up this PDO, we're going to see we get kind of that dither action. And depending on how our lighting is set up a little bit and how our terrain, it's going to blend decently well. It's going to work decently well. And this is a fairly cheap approach. And we can also play around with that dither offset to make it more soft. And this is excessively cheap because it really is a 64 by 64 texture. So hit G there. Right. And like right here, there's some sections where I think it blends relatively well. Or let's say over here, you'll kind of play around with this as you deal with your landscape. But this technique is extremely cheap. And versus these very harsh lines, you can get a little bit more subtle kind of offset. Okay. That's just another more simple way of blending mesh pieces with your terrain that generally works decently well, and it's a lot cheaper and than most techniques that you might run into. Okay, I think that's a good space to have some Q&A. Okay, and if there's any other part of this people are curious about, we can dive into all of those, but we can also open this up to any questions about this or about anything regarding our programs or our boot camp or what we offer at Vertex. Then you guys can just open the floor up for a QA. By the way, just as a fun fact, those different buffers I was talking about as we wait for people to write out questions is right here. You can actually look at them all. Buffer visualizers, and you can see every single buffer. The scene buffer, normal, and so on. You can look at them individually as well. Let's say look at the world normal, for example. Whoa, everything was blue. Or you can let's say look at the base color, which is very similar to just looking at unlit. Or say just look at the roughness. How rough are we? Okay, look, fairly rough it looks. Okay. Circling back to earlier, what specs are you running on this machine? Wondering about Houdini. Okay, so it's not going to be crazy. So my machine is specced out just because I did my once in a decade upgrade. So it's one of the better computers that you can buy. I spent like $5,000 on this machine, but lo and behold, when I built a lot of this stuff, I had like a very old machine that I think was running like a 980 Ti. So if you are using legacy hardware, how we put it, if you are hardware challenged, I've built a lot of things in a lot of the examples and demos that are not going to kill your machine. You even with a modest machine, you can still follow along with a lot of this stuff. Someone who has decent Houdini experience, but very little material and texture knowledge. Is there any sort of intro materials on the bootcamp? Yes, there is. We I'll go ahead and stop sharing. Kind of the way we teach the boot camp a little bit and teach some of these things is to think about them in a universal kind of context where in some sense we want you to be a little bit software agnostic to a certain degree. So the same way you might think about data like attributes, you can think about shaders. So we can build up that shader intuition the same way. So we have a section where you learn the practical side of how to use Substance Designer and how to use Substance Painter and how to build materials in different contexts and also how to use Niagara. But also, if I'm working with data in Houdini, I'm working in an attribute context and I'm using Vex, right? And let's say I'm want to do something interesting with something along a spline or a curve, and I use something like convert line, and I get that distance calculation, or I use just distance along spline as a stop, and I have an attribute that's now at 0 to 1, or some actually it could be a distance value that's across that line. I can think about it that same way I would deal with data and drive SOPs, the same way I would with a coordinate, right? So if I have a texture coordinate or a world coordinate, that's just a number line. It's just a number that I can now or manipulate. Really, the goal here, the vibe is this. So like when you are an environment artist or a texture artist, or you kind of build this intuition if you're good in Substance Painter, that you're trying to get like a really good intuition between what those textures look like and what the finished shiny material will look like. So an artist who spends a lot of time doing that, like they can look at a roughness map texture or a normal map texture, and they just have a really good intuition immediately with what the surface properties of that material is going to look like. Okay, that just comes from a lot of exposure and a lot of feedback cycles. Similarly, we want to do the same thing when it comes to writing, authoring shaders or authoring any kind of data or attribute pipelines or assets where we're seeing gradients, we're seeing some range of data, but we're not, the output we're thinking of is like step by step of how we can turn that and manipulate that from a math perspective. We're kind of doing math with color, right? And we're getting an intuition about how that math is happening across a range of numbers by seeing those visualizations. So if you just have a linear gradient and you take the round of that, it's going to split in black and white bars because you have numbers that are 0, 0.5, and so on. And that approach to materials, we take that same approach to anything in Houdini and Vex. So like having like an attribute oriented workflow in Houdini will, I think, benefit you. Also, if you worked in COPS, that will also benefit you in working in materials. It should be fine. I'm using a Mac. Will there be using any Windows only programs? Well, I'll tell you is I think the everything's kind of built towards Windows just because Windows is what game development's done on. No one makes games on Mac or for Mac. We might do them for iOS, so we might have a build machine, but like anyone who builds for iOS is doing that usually on a Windows machine. But all these applications do work on Mac, so they have Windows versions for Mac, I believe. I mean, I don't use Macintosh computers, but if the only machine you have is an Apple machine, you should still be able to, like Houdini has Apple versions, they have Linux versions. I believe the Substance Suite additionally has those, so you can still find those. Usually, one thing you're going to come across is that the Linux and the Mac stuff is going to have less support usually, but you'll still be able to have all the same softwares. And the licenses that you'll get through the programs, it will still work just the same. But all the examples should the Houdini example should be portable. The Unreal examples you might have to play with a little bit just because those were built. None of them are code examples, so there's no build. So you should still be fine to open those on your Mac. Okay. Yeah, I think most of the tools that we use there's Mac versions of them all, so it should be fine. Again, I don't use a Macintosh machine, so I haven't tested them. Yeah. I'd say Houdini's probably the most supported on Mac. Because there's a lot of Houdini people who are just big like Linux, Unix type people. So And designer also works really well in a Unix environment. I think the biggest place would probably be Unreal, but I'm pretty sure that there's good Unreal versions on Mac. I just have never tested that and don't know many people who work in a Apple environment on with Unreal. Well supported. So yeah, it should be fine. You should be fine. Okay, dokie. Any other questions? Any questions about the program or anything else that we do here at Vertex?
Yeah, is that okay if I ask a question?
Yeah, you can use audio too. I'm
Yeah,
not
okay.
against sound.
Thanks, because I didn't know how to write it down. I was like, it's probably complicated. So I'm a 3D animator, and
Okay,
I'm kind
dokie.
of trying to change what I do a little bit, I guess, because of the state of the industry, and I'm
Hmm.
wondering how the hiring process is in technical as a technical artist. Like, is
Yeah.
it if you have a really good reel or if you put in enough work, like would that be enough to get a job, or would it be like a very complicated situation as well?
Yeah, so I guess like it depends on that question. There's a lot of things bundled in that question.
Okay.
So like when we say state of the industry, what are we inferring there?
I feel like I don't know specifically for technical artists, but I know for animators it's a bit complicated um to get a
Yeah.
job. I know there's a lot of people out there, not that many jobs.
Yeah, I
And
guess I don't perceive that. I think junior level work there might be a little bit of a challenge, but there's always a little bit of a break-in challenge for junior level work. I see a lot of jobs all the time for senior level work, but for juniors there's always a little bit of challenge just because break-in is difficult. Really, it's going to be the same types of things where this is a very general knowledge I'll say. So your portfolio and your reel are going to be very, very important, extremely important. It's going to be more important than anything else. It's going to be important more that, especially as a beginner, right? Like, at some point your work experience, is going to carry you beyond that, but also like network, and network is not like oh, who you met at a cool wine party. It's who have you worked with and just, working with a bunch of people. So even remotely through something like Discord and just making cool things. It can be a way to build up that type of thing. I mean, I worked at a couple of different double A's. I worked at Meta, but I've never applied to a single job. I always got those because recruiters reached out to me or because a friend of mine that I worked with on some fun little project, recommended me or said, hey, we could use your talent here. Um, Really, what I would say to everybody is we have a thing called ArtStation. Your work needs to look as good as the best stuff on ArtStation. That's the base expectation. You are in a competition with the greatest artists who have ever lived in the history of the world. Everyone has the opportunity and the benefit of living on the shoulders of giants. And if you go on ArtStation and you see the front page, your art needs to be just as good as that to land a AAA job. That really is just the expectation. So the best animators that you've seen in any game, you need to be able to produce that same quality or something proximate and showcase that in a demo. Now you don't have to. The thing is to actually make a game. There's all other kinds of parts and things. So having something that's a narrow slice of that's well made for portfolio pieces really is is much easier. So it's definitely doable. And even having something modest where you have two or three pieces that are just really strong can be good enough. Uh, you know, you want to show your best things. You want to show real time quality work. And somewhere between you can get to a point where you have a lot of things in your portfolio, or really just a modest amount would be 10 or 20. But even just like three really strong projects can be enough. And then you just meet people and go to find out opportunities like um, GDC and SIGGRAPH and places where you can talk to recruiters. Reach out to recruiters on LinkedIn. Like these are people. Don't ever feel weird about reaching out to industry professionals. A lot of industry professionals leads will definitely like to talk to you and or mentor people. And especially in the context of recruiters, you're doing them a favor. Their job, you have different tiers of recruiters, and oftentimes you have a person called a sourcer, and their job is really just to sit around and find good, talented people. So like if you're coming to them, you're actually helping them out a little bit. So if you see a cool application for a job you think that you might be qualified for, you look at that job description and you feel like, oh, I have these skills. Look up the recruiters that work at that company and message them on LinkedIn and say, hey, I've applied here, and hey, I feel like what's the best way to get me, in contact with the leads or so on, and just say, hey, I want to formally contact you, and you can start that conversation process. You pass them your portfolio and so on. And really, as far as like how does that process work, it's going to depend on the studio a little bit, but really it just depends on the needs of the team. So like when I was a lead at Mob Entertainment, I had a team there, and I also helped do the interviews with my art director for every artist that we hired. We sized up and hired maybe around, I think, 80 artists, and I did all those interviews. So I maybe interviewed around 200 people. And really, it's just going to come down to what we need. Okay, so in your mind, in one space, especially when you're trying to break in, you're thinking, oh, there's all these different things I need to know and do and so on. But really, what you want to do is specialize, because what I'm looking for is what I need right now. I just need a guy who knows Max script. Okay. I need a Max script guy. Okay. Or that's the weakness of my team, where I just need a guy who's really good. Like the animation team keeps, hounding me about not supporting them enough. I need a guy who can dedicate on technical animation support. Or I need a guy who's really good at material shaders so he can help support and build our master materials for landscape. Really, that job description is going to be built out of that outline. Most people will just write a simple outline based upon the things that they actually need and have ChatGPT make the actual formal thing. So read in the bullet points, especially. Don't see a lot of these things as like like a hard thing where it says like you're must have like a certain number of years experience or whatever. Obviously, if you know you're not a senior and it's a senior thing, don't apply for it. Junior, still apply, but understand that like usually these are going to be looking for a specific type of person because it's the specific need that they need at that given time. And what's going to do most of your talking is going to be your portfolio. And for animation, real matters a lot because obviously moving is going to matter. Okay, in what ways can we prepare for the course, software, hardware wise? Well, I'd say you can pre-download side effects. You'll get a education license as part of the course, so you'll just wait to like install the license, but you can go ahead and begin with the apprentice license, which is the free license, and download Unreal. But as far as like we start from a pretty basic level. I mean, we generally our boot camp especially has has a lot of people who are some kind of industry professional or some we got a faster pace there, so like anything's kind of fine. Game jams, you done any? I love game jams. Okay, especially when I was a little old. At this point I've been doing this for about 10 years, a little bit longer maybe than that, and I love game jams. When I was a student, I would do a bunch of game jams. Great a great space to kind of learn very fast, especially if you can do like for real game jams where you're in person and do the 72 hours. Because what I find that's awesome about it, especially if you're getting, it can be the perfect antidote to burnout. If you're getting really bogged down with building portfolio projects or working on particular things, doing it like a little game jam, making something entirely different that you couldn't have thought of beforehand, and just 72 hours can be amazing. And what's really great about it too is you just when you're doing something hard, you can think back to when you were God mode. It's hard to explain, but like something will happen in those last 2 hours when you really have to get it in, and you can just pull off insane feats under that pressure where you can just go so fast. I remember there's some examples where I built in whole terrains and entirely textured them by hand and just had to get something in 30, within 30 minutes was able to build huge amounts of stuff at a unbelievable speed because there was a good pressure. And thinking back to those, I can be like, okay, if I can do that, I can do this. I can get this in by a certain deadline or so on. So they can be good for all kinds of reasons. Also, can be good to test out certain art styles and so on. So you come in with some kind of goal a little bit, but also try to be a little free form because there's going to be a theme and so on. You want to be a little free to that. But having friends, having developer friends, having guys who are good at the design side and maybe good, someone knows of guys who know the programming side a little, like some blueprints or someone can do some of the gameplay side. And if you're someone who's more of an environment artist, you have friends that are maybe good on the character and animation side, you can kind of make something a little fun. I think they're definitely worth doing. I study character art for games at Think Tank. Cool. But I'm also very interested in tech art. Would I be able to do a capstone project that involves character-centric tech art, like VFX material here? For sure. A lot of our program really focuses heavily on like procedural approaches, and we do more VFX and environment art stuff. But definitely, we've had a lot of people who are tech art or sorry, technical character and technical animation individuals, and they have done different capstones. We had one that was kind of cool where we posted on LinkedIn where someone did a bunch of Vertex animation textures, basically caching these textures into a type of like world position offset shader and was able to like blend between those for like a nightclub scene. So 100% we give you a lot of freedom for the capstones. We give you actually quite a bit of freedom and different types of things as long as we we approve that it's technically interesting. It's something that a lead who sees that in your portfolio project would think is cool and think is something that's impressive enough. But we give you a lot of aptitude about what you actually want to do because it's your portfolio, right? Um, okay, let's see what else. Let's. How many years of consistent work and practice does it take to become proficient at these things? Proficient means that you typically have a good idea of how to work on these things and get pretty much any result without help. Let me show you guys the meme, okay? That's a really good question. Okay, give me a second. Give me a second. You guys, is any of you guys, maybe the people who have used Houdini, have you guys ever seen the Houdini difficulty curve meme? Uh, Now I don't think this is true anymore. Okay, this was like maybe true in the past more so than now. Um, but it's just it's a funny little visualization. Regardless, let me share my screen. So this is a little chart. It's a graph learning curve of popular 3D software. And we have in red, we have our Blender friend, we have Maya, we have Max, and we have they have a little bit of S curve. Maybe they say Max is a little easier at first, and so on. And in Blender, maybe it's like a trend line in between those. And we look at Houdini, which is point to hawk here, and it has all these fun individuals along the way, and then you get up to the very top. So it's a little humorous, but there's the two bits of truth from it. Okay, in the past, it was a lot harder to learn this tool because there wasn't as good learning resources, and because there was this initiative they made at Side Effects called Side Effects Labs. It used to be called the game dev department, but they built a lot of tools to make things way easier. So I will say it's a little bit overspoken. We're actually, I think, learning it these days is a lot easier than like when I started. But there's another truth in here that people don't usually focus in on, and it's the dude at the top in that wheelbarrow. Okay, the juice is versus squeeze because at some point you get to be him, okay, and you're just plowing it, okay. So you really can become, I'd say it is a little bit tricky, and this is what I would say as an intuition. When I was first learning, I would talk to other tech artists I knew, and I'd say, and we all would agree usually, like I learned Substance Designer in about most software you can pick up in about maybe a week or so. I'd say I learned Substance Designer about like a day. I learned Painter in about 2 or 3 days, and ZBrush just because it has a little bit of an odd UI. I learned it. Maybe it took me a week, maybe we can have to really get fluid at it. Houdini, it took 2 years to get comfortable, which is usually what most people would say. It takes like 2 years to get comfortable where you really feel like you know what you're doing. But that was then. I'd say now to feel comfortable maybe could take you a couple months. And what that really just means is that there's a number of things you can do with the little nodes. And learn the nodes. It's like a language, right? To speak, you have to know a certain amount of vocabulary. You have to understand how sentences go together. So you have to learn. If you really want to take an active approach to learning tools, what I would say is just how you open up the tools, the tab or whatever, pull out all the nodes, investigate and learn them each, make notes of them, and then learn how they can be kind of used together. And that's the vocab and that's the sentence structure. That's learning the grammar. And yeah, so I mean, if you now that's very dedicated. So like 2 months to 4 months, you really can get to a point where you really know. Now the full scope of mastery. There's a couple parts in this tool that I don't have fully mastered just because I don't work with it a lot. So like some of the deep into the particle stuff, like because mostly that's for like TV effects or movie kind of effects. I don't know that very deeply. There's a couple other small parts of the tool, I haven't used, but I've been using this tool for like 9 years. Well, I think I used it at college a little bit, but really getting into it deeply, like not 8 or 9 years. But there's only a handful of domains that I don't have like full, pretty deep knowledge of. Um, but you can get to a point where you can make cool things and you can have an intuition for things if you're well directed and dedicated within like 2 to 4 months. Not too bad. Okay, I think. Let's see. Let's see. Okay, I think there was one more. You mentioned it's hard for entry levels to break into the industry. Do you think internships is the best pipeline, even if you're well, what I'll say is that this just it's a little bit of I don't know. So it's a little bit of I just don't see those jobs as much, but also just could just be my algorithm on LinkedIn doesn't show me a lot of junior work just because I'm not a junior, right? So there definitely could be places like when I was in the industry, I did a lot of like when I was breaking, I did a lot of my site, like shit jobs might be, or I just did a lot of small contracts just to build up that work experience. That's one way as well. Internships can be great too. All those are great, right? Like there's plenty of ways that you can get in. Really, the work experience is the super important thing that matters. It's some people they can get like an internship or a junior level experience right out of college. Some people they don't, right? And that's more has to do with like opening your already having that portfolio wrapped away that's nice and strong, and then making yourself available for opportunities to meet those leads and build those relationships. Yeah, and just a note on networking. You want to talk about the work, talk shop. Okay, so there's one level that's being kind of personable and so on, but really they want someone who loves this. Okay, who like this is entertainment. Okay, definitionally, a lot of people want to do it. Okay, and there's a limitation on there's a natural limit on the number of jobs available because if everyone did it, then right, I put it a different way. Okay, if you go to a concert, okay, and everyone can't be on stage because if everybody was on stage, that would be called the audience, right? Definitionally, the attention has to go into a limited space, right? So there is just some limitation by basis of economics about who can be doing entertainment and how many jobs that can build up. Now, luckily, we're not, it's not unlike something like music or oil painting or whatever. Like a studio can be hundreds of people, so it's quite a few jobs around here, okay? And it's all different kinds of ways you can make money doing games or 3D or something similar. But the people it tends to fashion a type of person who's extremely motivated and dedicated and loves this shit. Okay. So they want to talk about it. They're interested in it. Okay. And they're really interested in about what other people are doing, what their workflows are. Oh, have you tried this new this new thing or whatever? So like being able to just talk shop and talk about that, that's the character or the sign of thing that a lot of people will actually want to do. If I'm talking to people, I will remember the student or the junior who is able to talk about the approaches they're doing, and they're actually, oh snap, and it kind of impresses me because that's the same kind of things I am. And this is like you can't get anything by someone. You can't like do some like we have seen everything. Like someone who's a senior or junior, they have seen every tutorial that you've probably ever watched. They've already seen that because the amount of hours that we'll put into this is insane. We're familiar with all the same names. This is one of the biggest things in an interview. I see someone's work and I see me and like the art director or the lead environmentalist, we might see that the person's work and we'll have questions for them about the technical side and the approach and the performance. But we'll also have technical, hey, what was your inspiration for this? I see this is a concept artist that we all are familiar with because, we've all seen them from like an 80 level posting, or you might see certain approaches that they've done for a certain like type of stylization from a particular game. They're getting into this. There's like a subculture of each discipline of art for character art or environment art or so on. And that's the type of things people want to talk about. Okay. So that's the type of things that really you can, because there, as well as there's understanding, um, that you understand how to do all things. We want to talk to a tech artist. We want to talk to an environment artist. We want to understand that you are on the same wavelength, that I don't have to spend because it's almost like a subculture. You have to, if I'm communicating to you, I can use shorthand by referencing a bunch of pieces of art or a bunch of things that you would only know if you were in this world and that you had like spent the time to learn how to get good. Getting good is looking at other people's work and seeing what they do. Everyone puts their stuff on ArtStation. Everyone follows things like experience points or an 80 level, and you can just look at all the different ways to approach making things. Yeah, I think like that's a really good, if yeah, nerd out about it, right? You should be excited. Uh, you know, and that's another thing that's great about interviews. It gives you a place to, we want to hire someone who's excited to work for us, right? Like if someone's like whatever and oh yeah, or like nervous sounding versus someone who just sounds like it's just like they could talk about it all day just because it's just what it's like, it's like they talk about D&D or something, right? It's like it's what they're excited about, right? What brings them joy. That's the type of person that we want to have on our team, right? And that can even go a little bit more. Like if there's one person, two people, and one person's work is even a little bit better, right? But the other person just is so enthusiastic, that's usually gonna be more important, just because then we want people who are good team players and want to work for us instead of someone who, is kind of whatever, too cool for school. I think with that, I think that might be a good space to kind of stop. Okay. I really appreciate everybody coming out for this Tech Art Open Day. This recording will be kind of emailed out to you guys. I think also it will be tossed up on LinkedIn. And I hope that you guys will join up for our program or our boot camp, and I'll see you guys in one of those terms.
I'll be there.
Thank you guys.